Hello there. My name is Alex Sheffield. I study neuroscience at the Colorado College. This summer, I worked at the Berenson-Allen Center for Noninvasive Brain Stimulation, a research and treatment facility out of Beth Deaconess Medical Center in Boston, Massachusetts. My internship was funded by the Summer Internship grant of Colorado College. I worked with Dr. Emiliano Santarnecki, where my primary obligations were cleaning and processing TMS EEG data to study the neural correlates of intelligence. I will briefly explain TMS EEG now. TMS stands for transcranial magnetic stimulation. A TMS device looks somewhat like a figure-8 coil like this. A brief electric pulse is sent from this end of the coil outwards in this direction. This causes a magnetic field that, when applied over an object such as the brain, creates an opposing electrical current in the brain. This electrical current causes neurons to fire or undergo action potentials, during which they briefly become very positive. EEG is electroencephalogram. This is where we place electrodes on the scalp and read the voltage, or how positive or negative regions of the scalp are relative to other positions. An EEG reads on a line somewhat like this. Over time, synchronized brain activity will generate positive and negative voltages that we can read. Combining these two approaches, we can send a pulse of action potentials to a certain brain region, and then using EEG, watch as this activity propagates throughout the brain. The colored circles represent various brain regions that I will continue to refer to as nodes. The red node is the brain region where we initially send the TMS pulse. You can see EEG is connected to some of the other nodes in the brain, with the black line showing the time where the TMS pulse was sent to the red region. The orange nodes are the most strongly connected regions of the brain to the red region. We know this because there is a strong inflection and deflection in the EEG immediately following the TMS pulse. The lighter orange regions represent brain regions that are not as strongly connected to our red region of interest. We know this because there is a slight delay between the TMS pulse and the deflection in the EEG, as well as the deflection being smaller than for the darker orange. The yellow nodes are brain regions that are barely or not at all connected to our region of interest. We know this because before and after the TMS pulse, there is no change in the EEG signal. Due to interactions of the magnetic pulse that TMS generates and the electrodes of the EEG, TMS EEG data is riddled with artifacts that prevent the data of being of any use. This is where the majority of my job came in. Using a MATLAB script, I would dissect the data into independent components and then would remove components that were artifactual and not from the brain. When this was complete, I could then analyze the data and see the brain's response to the TMS EEG pulse, seen here. Here's a picture of myself with my mentor, Dr. Emiliano Santarnecki, to whom I owe an enormous gratitude. His work ethic, curiosity, and limitless passion for his work has reaffirmed my decision to continue to pursue neuroscience through graduate studies and beyond. He stands for everything that I love about the sciences, and I could not have asked for a better advisor as I begin my scientific career.
Teach them from all their roots and culture that's been in front of them face.